Okay, so day 2 of 1.2, angle relations in similar triangles. Today we're going to talk about congruent and similar triangles. Congruent triangles have the same shape and the same size. Again, geometry stuff here. Corresponding angles have to be congruent. Corresponding sides have to be congruent. So as you can see in the picture, those two angles look exactly the same. Same angles, same shape, same size, everything. However, similar triangles have the same shape, but not necessarily the same size. So on this one, the corresponding angles have to be congruent. The corresponding sides do not have to be congruent. However, they do have to be proportional. So you can have that angle be 2 times the other one, 3 times the other one, 4 times the other one. An equilateral triangle is the best one to show, because an equilateral triangle, they're all 60 degrees. All 3 angles are 60 degrees. But you know that we can have a itty-bitty equilateral triangle, or we can have a very large equilateral triangle. But the size of the angles never change, only the size of the sides. Therefore, the sides must be proportional from one to the other. It's either 2 times, 3 times, half the size, however you want to look at it. Okay, so on the first example, find all unknown angle measures in each pair of similar triangles. And if you remember from geometry, that they will show different markings to identify the sides or the angles. Since this has one marking, angle C goes to angle P, so this angle is 78 degrees. 2 markings on this one, 2 markings on this one. So angle B and angle M correspond, so this angle must be 46 degrees. And that leaves us angle A and angle N. So angle A, or I should say the measure of angle A, must equal the measure of angle N. So we do our math, remember? 3 angles in a triangle must add up to 180. So we have 180 minus the 78 minus the 46. Now we don't normally do math like this, so it's really 180 minus the sum of the two, 78 plus 46. So 78 plus 46, handy dandy calculator, is 124. And if I take 180 and subtract that number from it, we get the last angle to be 56. So this one is 56 degrees, and this one is 56 degrees. So next one, this time, they're you're looking at the sides. They're not giving us any information about the angles. We can't go, oh, well, this one's 30, so this one's 30. No, we don't know it's 30. We can guess, but we don't know. But we can identify now, and I'm going to throw something out there that you guys should recognize right away. These are not to scale. Look at this one. If you, or even this one here, there's the double angle, the single, double, single, which means this side corresponds to this side. But obviously this number is larger than this one. So we're going to go with, they're not to scale. So this is the one where you have to remember that A over 10 must equal the B over 20, which must equal the 75 over 25. That is your proportions. This is just proportions. And that is what similar triangles tell us. So we can find the scale factor from the one we have both numbers. The scale factor is 3 to 1, because think quarters, think money. I have 1 quarter and you have 75 cents, means you have 3 quarters. It's a 3 to 1 scale. So we can actually calculate the other two now. So if I have a 3 to 1 scale, then it's going to be 3 over 1 equals a over 10. Cross multiply. And we get a equals 30. So this guy here is 30. 30 what? We don't know. It's just 30. And then the other one, if we use it, we get 3 over 1 equals b over 20, which tells us that b must equal 60. So this guy here is 60. And we're done. Oh, now let's look at this one. Woo, how do we set it up? I'm actually going to ask you to pause for a second and try it. Can you get it at least set up? Do you know what side our angles go, which side and angles? And go from there. I'll pause for a second. Okay, so we have, I'm gonna just do this so that I can see it better. I'm gonna label this triangle as A, B, and obviously this guy here will be C, and that's what these are vertical angles, so we know they're going to be the same size. But this is 40 and this guy's 40, so I'm going to label him as A prime. That's just to identify where what angle goes which angle. And this guy will become B prime. Okay, we have this is 18, this is 6. Oh, look, we got a larger angle to a smaller angle. Triangle. Yes, I get it. Smaller triangle, a larger triangle to a smaller triangle. So if we go larger to smaller, we have an 18 to 6 scale factor, or a scale factor of 3 to 1 again. Okay, so now we can do this one. We know where our scale factor is we just got to get everything else going on. But really, they just want to know, find the value of each variable. I need to know what is this side, or this variable, and what is this one. And all we really know is that we have a 3 to 1 scale. So I can identify this one, and this may not work for us as well as we wanted it to, because we need the sides. I know that 18 goes to 6, which is my 3 to 1, is going to be the same as, remember, larger to smaller, x plus y over x minus y. Now I'm going to go ahead and change this guy to the 3 to 1. So I have a 3 to 1 equals x plus y over x minus y. Cross multiply. And we get 3 times x minus y equals x plus y. So 3x minus 3y must equal x plus y. Now we move the x's to one side, the y's to the other side, so on and so forth. So if I move the x over here to here, move the y's the other way, I get 2x, these cancel out, equals, these two cancel out, 4y. So 2x must equal 4y, or x equals 2y. So at this point we can look at these going, I know that this is my larger side, 1, because this is my largest angle. And we do have to figure out what y is. So a lot of algebra going on here, because this only has a y in it. So now we're going, oh, we need this information. Maybe I should have started there, because this is going to be the easier one to do. Okay, so we put this guy on hold. We come up here going, I know that these three triangles must add up to 180. And 40 plus 82 equals 122. So I have 10y plus 8 plus 122 must equal 180. That angle plus this angle. So I have 10y plus 130 must equal 180. Look at that, 0 at the ends again. So this is just 1y plus 13 must equal 18. So y equals 5. We know what y is. So now we can solve for x. X equals 2 times y, but y is 5. So x equals 10. And this is where I get to point out they did not ask you to solve for the missing sides and angles. They asked you to solve for x and y. So you are done. Now, if you wanted to continue on, you could. And you can go in there and go, oh, look, that last angle is 10 times 5, 50, plus 8, 58. And x and y is 10 and 5. X plus 5, or I'm sorry, 10 plus 5 is 15. 10 minus 5 is 5. And now you have sizes as well. Okay. So how did we do? Did we do okay? I know a lot of work, so we did a lot of this work here and got stuck with x equals 2y, and then we went back and go, oh, wait, I can take care of this one as well. Okay, I think the next one is some word problems. Let's do some word problems. Yay! I can hear you guys already cheering. Woohoo! Okay. Height of a lighthouse. The Biloxi Lighthouse in the figure cast a shadow 28 meters long at 7 p.m. At the same time, the shadow of the lighthouse keeper is 1.7 meters tall. Who is 1.7 meters tall, is 3.5 meters long. How tall is the lighthouse? So our question is this guy right here. Okay, I can't draw. The question is, how tall is this guy here? Now, if we've got a shadow coming out this way of 28, too bad we don't have a lighthouse keeper out here. And we have a lighthouse keeper somewhere. Okay, here we go. Man. Doot, 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 doot. He's 1.7 meters tall, 7.5 meters tall, and his shadow is 3.5. This is still a proportion thing. Obviously, they are not the same. We get to assume they have a similar shape, but nowhere near the same size. So, an easy way to do this one is label things. I have a lighthouse, and I have a lighthouse keeper. I have a shadow, and I have a height. Okay, the lighthouse, the shadow is 28 meters long. His height, we don't know. The lighthouse keeper, his shadow is 3.5. And his height, 1.75. So what we have here, and I'm going to change colors for you, is we have our proportions set up for us. So I'm going to change colors so you guys can see this. What color shall we go to? Just go black. Okay. So I just want to get a little bit smaller line. So really, this is what I have. And you guys should be going, really? That's it? That's all I have to do? Yes, that's all you have to do. Woohoo! We're going to cross multiply. So 3.5x equals 1.75 times 28. So I have 3.5x equals whatever 28 times 1.75 is. Which is 49. Divide both sides by 3.5. And we get x to equal 49 divided by 3.5 gives us 14. 14 what? Oh, it's 14 meters. Now, here's the one thing I got to throw out there to you guys. Word problems deserve word answers. answers. So all you're going to do is take the actual question and answer it. How tall is the lighthouse? The lighthouse is 14 meters tall. Done. Word problems deserve word answers. Okay, proportional problems. So keep in mind that what we're doing at the time that we're doing things, when you get word problems, you should be applying something that you've seen in the book already, or something that we've been doing in that particular section. This is chapter 1, so obviously, we get to chapters 3, you may have to go, oh, this is a proportion problem. We did this in chapter 1, and you'll know what to do. Okay, remember I told you trig. You cannot test and purge. You have to remember what we did in chapter 1 as we move into chapter 2. You have to remember chapters 1 and 2 as we move into chapter 3. Yada, yada, yada. Okay, one more word problem and then we're done. Okay, solar eclipse on Earth. The sun has a diameter of 865,000 miles. We're in miles. With a maximum distance from Earth's surface at 94,500,000 miles. The moon has a much smaller diameter of 2,159 miles. By the way, there's the moon. See, there's the moon. For a total solar eclipse to occur, the moon must pass between Earth and the sun. The moon must also be close enough to Earth for the moon's umbra, or shadow, to reach the surface of the Earth. Calculate the maximum distance that the moon can be from the Earth and still have a total solar eclipse occur. So a lot of information going on here. So before I lift the page up, I'm going to mark things in there. So I have 865,000 is my diameter. Okay, I lost my pen. There it goes. So 865,000, that is my diameter. The moon's diameter is 2,159. And the maximum distance that the sun is from the Earth, so this is the whole entire distance, is 94,500,000. Now, if you know scientific notation, you could play with it if you want. I'm not going to, because I don't want to confuse somebody who's not familiar with it. But we're ready to go now. Just like the last problem, we have the sun and the moon, and we have a diameter, and we have distance. So the sun, the diameter is 865,000. There we go, I got it. The diameter of the moon, 2159. The furthest distance the sun is from the Earth is 94,500,000. And the moon, we don't know. So just like before, we're going to change pins again. Let's go to red. Just like before, set up your fraction, and you have an equal sign, and you have your proportion set up. So this over this, you can reduce if you want. I'm going to, because we have a bunch of zeros on this side. I have 3 zeros. I'm going to cross them off with 3 zeros on this one, so I don't have so much to look at. So I have 865 over 94,500 equals 2159 over x. Cross multiply. And you get 865x equals 2159 times 94,500. So this gives us 865x equals 204025500. Divide by 865. So if we get a value of x equals 235,867.6301 miles. Now let's go back to our question so that we can give it words. Calculate the maximum distance that the moon can be from the Earth and still have a total solar eclipse. So we're just simply going to put in there the maximum distance that the moon can have from the Earth, the maximum distance is 235,867.6301 miles. And we are done. Big number, I get it. We got the same number if you played with scientific notation, but I don't want to do something like that that somebody may not have seen before. And I do believe this is going to call it an end. And then you guys have the homework that we will be playing with tomorrow. Okay, good luck. Have a good night's sleep. Thanks.